my dear students. Welcome to India's biggest online platform, ME Educational Institutions. We can also draw stress versus strain diagram for different materials. Let's start the session. See here, we already discussed the definition of rigid body and elastic material, plastic material. You will be discussing one by one in detail. Stress versus strain diagram for different materials. In that, what is the stress versus strain diagram for rigid body? Rigid body is the body in which deformation is negligible even you apply infinite amount of force. Zero deformation for infinite amount of force is nothing but perfect rigid body. If it is perfect rigid body, deformation is zero even you apply the load. That is why you will be getting a line along the stress axis. Deformation is zero. Delta L equal to zero. Okay na? For any amount of load, deformation is zero. It is negligible deformation and it is approximately equal to zero. That is the perfect rigid body. It is an assumption actually. So there is no perfect rigid body in nature. So this is assumption like ideal gas and ideal fluid. Okay, now those all are assumptions like this. In rigid body mechanics, rigid body is nothing but negligible deformation. Coming to elastic material, perfect elastic material. It is having an inclined line. It is an inclined line. Slope is constant throughout the stress versus strain diagram. The slope theta, Young's modulus of the material, or this you can represent it E also. This is nothing but sigma by epsilon. Constant slope. Okay na? So here slope is constant. Slope is constant throughout the diagram. Slope is constant throughout stress versus strain diagram. That is the perfect elastic material for rigid and plastic material. So up to here it is rigid. This is rigid material and a line which is parallel to the strain axis. This is plastic. I can say that this is perfect rigid and plastic material. Up to some load, it is behaves as a rigid. After that, it behaves as a perfect plastic material. That is why you can call it as rigid and plastic material. Now coming to elastic and plastic material. Elastoplastic, up to here slope is constant. So up to this point slope is constant. After that a line parallel to strain axis, slope is zero. Here it is slope is constant. This would be the slope sigma by epsilon. Y equal to E equal to sigma by epsilon. I can say that up to here it behaves as perfect elastic. This is plastic. This is the plastic curve. A line which is parallel to strain axis. Elastoplastic material. Next coming to this elastic and strain hardening plastic material. So this is called up to here constant slope. Up to here constant slope. Slope is constant. So that is why you can call it as tan theta equal to sigma by E. Up to here elastic material. After that it behaves, this is called strain hardening. This is nothing but, this would be strain hardening plastic. So strain hardening, hardened plastic. This is the process of strain hardening. Okay, now. So next we can say strain hardening with unloading. So it come back to its this up to this position. For once you do unloading, up to here, this is elastic. Up to here, elastic, strain hardening with unloading. This is unloading. Unloading. Okay, so this is theta, sigma, epsilon. I can say this is elastic. Elastic. Here it is what? Strain hardening. Strain hardening. Strain hardening with unloading. Okay, na? So this is called unloading, strain hardening, and elastic. Elastic and strain hardening here. So here it is what? Elastic and plastic material. These are the different materials and corresponding stress versus strain diagram. Please do subscribe METube Intel Physics YouTube channel. Thank you. We can meet in the next class. Thank you.